So when naming anhydrides, we have to recognize that this molecule was formed from two carboxylic acids. So we're to split down the middle of the molecule. It was formed by an acid with this many hydrocarbons, this carbon chain, and an acid with this carbon chain. It's actually two different acids that combine together. So in order to name it, then we kind of, like I said, split it down the middle, count the carbons on one side, count the carbons on the other side, and then name it based off of that. So it'll be something something anhydride. And so in order to name it, it's going to be based off what the acid was that had to be there to form it. So this is a two carbon chain, so this would have been ethanoic acid, and on this side this was a two carbon chain, so this was also ethanoic acid. So technically I would be writing ethanoic, I'd have a space, ethanoic, and then I would write anhydride to finish it off. But we need to recognize that there are two of these. And normally we would write the word di in front of them, diethanoic anhydride, but it's not necessary in this case because it's a symmetric molecule, and we have to recognize that if I only say one of these, that it implies that both sides are the same, same carbon length, same carbon chain on either side. So let's try that out then. So if we were to go through with this and check out the carbon chain on it, I would say then two carbon chain, it's symmetric, it's the same thing. It's an ethanoic acid that it was derived from, so ethanoic. Let me try that again. There we go, ethanoic. And now instead of acid, I'm going to put anhydride. And what this implies then is that the ethanoic acid was used, and because I don't put another acid in front here, it implies that both sides are the same, and it's a symmetric anhydride across this oxygen here. So let's try an example where it is not symmetric. So on this side here, I'm going to split through. I have a two carbon chain and a three carbon chain. This was derived from ethanoic acid. This was just derived from propanoic acid. Alphabetically, I'm going to say ethanoic, and then I'm going to say propanoic. Note this is a space. Propanoic, and then anhydride. There is a space here in between. I had no room, so I put it down below here like this. So there's an example where I've got, I have to indicate the two acids because it's not a symmetric molecule. Moving on, we've got a compound where we're splitting down the middle here. We can see it's definitely not symmetric. So we'll have to name both sides of the acid, even though the carbon chain length is the same. On one side of 1, 2, 3, so this is a propanoic acid. This is also a propanoic acid, but there's a methyl group on it, so we have to indicate the two of them. So this will be a 2-methyl propanoic. And then I have to indicate the other side. This is a propanoic. And then anhydride to finish off. I will write that properly for you in a nice little box. So similarly then, I can get to a molecule that is more symmetric. Even though it looks complicated, we don't have to write out the full name of it because of the symmetry. So I'll erase this here as I go, and we'll start to name this one. So on one side here, the acid was 1, 2, 3. It's a propane group, so it's a propanoic acid. And in the 2 position is a methyl group. But same on the other side. So 1, 2, 3, this is a propane group. In the 2 position is a methyl group as well. So I only have to write it once. 2-methyl propanoic. And then I'm going to say anhydride. In the space there. And so this implies then that both sides of the molecule were derived from the same acid. Another example with an asymmetric anhydride. So if I split down the middle here, 1, 2, 3 carbons. So I have a propane with a methyl group on it. 1, 2, 3, 4. This is a butane with a methyl group on it. So alphabetically, the butanoic comes before propanoic. So I've got a methyl group on it, so a 2 methyl butanoic 2 methyl propanoic anhydride. And that should be up here with no space, sorry, with a space after it, but I just don't have the room. And there is a space here as well. And finally, in our last example, it looks like it's a symmetric one again, even though it looks complicated. It's the same on both sides. I have 1, 2, 3 carbons on this side, and then I have 2 methyl groups hanging off the number 2 carbon. And on this side, 1, 2, 3 carbons as well, and I have 2 carbons hanging off the 2 position. So this is a symmetric molecule. I don't have to name it twice, essentially. So in the 2 position is a methyl, in the 2 position is another methyl. So I'm going to call this a 2,2 dimethyl propanoic anhydride. See how I can fit this. Oh, I did it. Hooray for me.